Please refer to problem number 19. In this case, an inclined plane is there. A sphere rolls down the inclined plane and a disc rolls down another inclined plane. Both are similar inclined planes and the same distance is covered by both the sphere and the disc. And we have to find the ratio of time taken by the sphere and the disc. You know that s is equal to ut plus half at square, so that becomes u is 0, so we can write s is equal to at square. Since the distance covered by the sphere and the disc are the same, so we can write s1 is equal to s2, that means a1 t1 square is equal to a2 t2 square, where a is the linear acceleration of the sphere and a2 is the linear acceleration of the disc. T1 is the time taken by the sphere to reach the bottom, T2 is the time taken by the disc to reach the bottom. And you know that for an inclined plane, the acceleration is given by g sin theta by 1 plus k square by r square with a, okay, for a sphere we know that k square by r square is equal to 2 by 5, and for a disc k square by r square is equal to 1 by 2 for a disc. This is for a sphere. So we can find the value of a1 and a2 now, and finally the ratio is to be found out. So t1 by t2 is equal to a2 by a1 with a root, and now we substitute the values. A2 is equal to g sin theta divided by 1 plus 2 by 5, because sorry, a2 is for a disc, so that becomes 1 plus 1 by 2. This is g sin theta by 1 plus 1 by 2 is 3 by 2, that is 2 by 3 g sin theta. So we got the value of a2. Therefore a1, which is for a sphere, this is g sin theta by 1 plus 2 by 5, that is equal to g sin theta by 7 by 5, which is nothing but 5 by 7 g sin theta. Now we got the values of a2 and a1. Putting in this equation, this becomes root of a2 2 by 3 g sin theta divided by a1 5 by 7 g sin theta. G sin theta cut out, therefore t1 by t2 becomes root of 7 2s are 14, 5 3s are 15, so that is root of 14 is to root of 15. So the answer is root of 14 is to root of 15. It is what t1 is to t2, so which is nothing but option number 4.